Okay, good morning, Professor David J. De Los Reyes. It's August 27, 2023. The time is around 2:33 EM. August 27. Okay, my discussion for this morning will be a long format video discussion on alternating current circuit, and this will now be a continuation of the last lesson, the so-called delta to Y transformation. For this morning, we will be taking up the so-called Y to delta transformation. Okay, let's proceed. The subject matter for this morning will be alternating current circuit, lesson number 32. The title of the topic will be Y to delta transformation. Okay, let's try to bring out the figure. The figure will be this. The transformation is from Y to delta. Okay, Y to delta. So, meaning to say, if we are given a Y-connected impedances, to get the equivalent of this in terms of delta, this should be the delta equivalent. Okay? We must have to bring out this equation here. So, as a representation for the figure, we let C sub A, C sub B, and C sub C be the impedances that are connected in Y, the given impedances in Y. CA, CB, and C sub C. Okay? And the equivalent impedances in terms of delta, the designation will be different. So they should be C sub 1, C sub 1, sub 2, and sub 3. C sub 1, C sub 2, and C sub 3. To get the equivalent impedances in terms of delta, in general, I'll place it here. Capital letter Z with the subscript delta, meaning the equivalent of the given Y in terms of delta. Okay? It will be the summation of the product of the impedances taken, or summation of the product of two impedances, taken at a time, okay, meaning the impedances in Y, right, divided by the impedance opposite in Y, okay. Actually, we could translate this notation here in terms of an equation, because if we try to summarize this one, we could represent this one in terms of an equation. We will let the numerator to be ZACB, C sub C, C sub B, C sub C, and C sub C, C sub A. The two impedances taken at the time are actually CACB, CB, C sub C, and C sub C, C sub A. Okay, the impedances in Y are actually ZA, CB, and C sub C. So the numerator, according to this notation here, take the product of the individual, two impedances at a time, CA, CB, the product, right? Plus the product of CB, CC, plus the product of C sub C, C sub A. Okay, that's the numerator. Two impedances taken at a time, right? The one and Y connection, right? To compute for the value of Z1, according to this notation, it will be this value here divided by the opposite impedance, okay, in Y. Like if we try to consider C sub 1, okay, the opposite of this in Y is actually C sub C. The numerator is C sub C. So if we are solving for C sub 1, the denominator should be C sub C. Okay? The numerator, it's the individual summation of the product of two impedances taken at a time. That is CA, CB, CB, C sub C, and C sub C, C sub A. So for all C sub 1, C sub 2, and C sub 3, the numerator are the same, right? But for C sub 1, the denominator will be its opposite considering the y connection. So the opposite of C1, okay, on y is actually C sub C, right? Considering C sub 2, if we try to compute for C sub 2, where C sub 2? This is C sub 2. So C sub 2 will be, the numerator will still be the same, the summation of the individual products, okay? Two products at a time, the summation, okay? And the opposite of C sub 2 in y is actually C sub b, right? It's opposite. So the denominator of C sub 2 will be C sub b. Considering C3, the numerator will still be the same, the summation of the product of two impedances at a time. So this is 1, 2, 3, right? CA, CB, C sub B, C sub C, C sub C, C sub A. They are all the same, right? And the opposite of, if we try to consider a compute for C sub 3, its opposite in y is actually C sub A. So the denominator of C sub 3 on the formula will be C sub A. That's it. So actually, we are given three impedances or three equations on how to convert a given y to its equivalent and delta. That's it, guys. The importance of this y to delta transformation is that there are problems in which if we didn't convert from y to delta, we could not solve the problem. We cannot just use the ordinary series parallel concepts. Because maybe after the transformation, okay, if we try to look at the resulting circuit, it will now be what they call this a solution that will be using the so-called series parallel concept. So it is a must that we should know how to convert from y to delta. Okay, that's it, guys. So for those of you who are taking up electrical engineering, this is for you guys. If you want to subscribe to my channel is at youtube.com/@prof.dvj. If you want to share it, please click share. Good morning from Los Angeles, Professor David J. De Los Reyes.